Welcome to the iHistory channel. In today's episode, we tell you the story of the carrier made of ice. Early in 1943, in the Smithfield area of London, a refrigerated room inside a meat store became a workshop. The object under study was ice, altered by wood pulp. Large blocks were made there from water and frozen wood pulp. The mixture was called Pike-Crete, after Geoffrey Pike, whose bird-ship idea had moved through Combined Operations headquarters. This was not ordinary ice. In tests described by Max Perutz, hammer blows did not make Pike-Crete shatter as plain ice did, changing a strange proposal into material science. Small arms rounds did not crack the test lamps. Strength work went to the National Physical Laboratory, while explosive testing went to the Road Research Laboratory. The cold room experiment pointed west, into the mid-Atlantic air gap. Britain wanted a floating airfield beyond land-based patrol range, where shipping still needed protection. In 1942, Geoffrey Pike carried an audacious proposal through Combined Operations headquarters. It was a giant floating airfield, imagined for the ocean space ordinary patrol aircraft could not reliably cover. Pike's first scheme was not yet Pike-Crete. It belonged to an earlier family of iceberg and bergship ideas, using the sea itself as the foundation for an artificial base. The need came from the mid-Atlantic air gap. Convoys crossed water beyond land-based patrol range, where shipping protection thinned and the Atlantic War demanded improvised reach. Combined Operations was built to test strange answers under pressure. Its chief, Lord Louis Mountbatten, was a sponsor of eccentric wartime ideas and helped carry Habakkuk upward. Mountbatten's role did not make the carrier real by itself. It did give Pike's concept an official channel and a path towards senior wartime attention. Winston Churchill also backed exploration of unconventional solutions to the Atlantic shipping crisis. Habakkuk reached him personally, not as a public fantasy, but as a wartime possibility. The paper trail rose further. The project reached the War Cabinet and the Combined Chiefs of Staff, placing an ice carrier among the highest problems of Allied strategy. At this stage, the name often appeared as Habakkuk in official paperwork. The spelling shifted, but the pressure behind it remained the same. The proposal began before the reinforced ice material was perfected. It was first a strategic answer, then an engineering question, and only later a Pike-Crete ship. That sequence matters. Habakkuk was born from a gap in coverage, not from a laboratory trick with frozen wood pulp or spectacle. Senior interest did not mean certainty. The record supports a serious proposal, channels of command, and high-level attention, but not a completed ship waiting on the secrecy in the Atlantic. In 1942, the idea still looked like a floating island made useful by design. It promised an airfield where geography had left none. That was the beginning of Habakkuk's power. It joined fear, imagination, and bureaucracy in one proposal. A carrier not yet made of Pike-Crete, but already made of urgency. Then the idea changed substance. In February 1943, Mark and Hohenstein at Brooklyn Polytechnic found that small amounts of wood pulp made ice tougher and less prone to cracking. For Habakkuk, this was revival. The bird-ship was no longer only an imagined iceberg airfield. It now had a material with a name, a recipe, and tests to endure. The code name was Pike-Crete. It meant Pike's Concrete, a wartime label for frozen water reinforced with pulp attached to the man who had driven the carrier proposal forward. The working mixture was not a single magic formula. Perutz described a range, generally 10 to 15% wood pulp in water, for the material under wartime study. The familiar 14% pulp and 86% water recipe belongs to later shorthand. It is useful, but it should not replace the broader wartime range. Max F. Perutz became the crucial scientist in the story. His subject was not romance or spectacle, but frozen wood pulp, frozen water, and the slow movement of loaded ice. In London, the work left the level of table demonstration. A small research unit made large Pike-Crete blocks in a refrigerated room inside a meat store. The National Physical Laboratory tested strength. The Road Research Laboratory, under the Department of Scientific and Industrial Research, tested explosives, while Admiralty Scientific Direction held the program together. The results made Pike-Crete look astonishing in impact. It did not shatter under hammer blows like ordinary ice, and small arms rounds did not crack the test lamps. But impact was the simpler danger. The larger threat was creep, continuous deformation under sustained load, the patient sagging of a ship expected to carry itself. Perutz discussed a stress threshold of about 7 kilograms per square centimeter. Above that level, deformation over time became a central design problem. Temperature became structural policy. For the ship concept, Perutz gave about -15 degrees Celsius as the highest permissible working temperature to avoid unacceptable creep. At that temperature, the creep threshold corresponded to a column of ice about 7-8 meters high. The number turned cold strength into naval geometry. Paicrete gave Habakkuk a material basis, but not a solution. The material could resist blows, yet the proposed carrier still had to resist time, weight, and warmth in any future service. The next step moved the experiment across an ocean. In spring 1943, the National Research Council of Canada took on the larger work under the direction of Prof. F. M. Williams. Britain had proved the material in cold rooms and laboratories. Canada offered space, winter conditions, and an institutional base for building something bigger than a block on a test bench. The principal experimental site became a mountain lake near Jasper, Alberta. Patricia Lake was remote enough for secrecy, yet reachable enough for equipment, labor, refrigeration machinery, and official supervision. There, in March 1943, a floating prototype was completed. It was not the ocean carrier, but it was no drawing room fantasy. It existed on the water. Later, Canadian archival summaries described the model as about 60 feet long, 30 feet wide, and 20 feet deep. Its weight is given as about 1,000 tons. Those measurements matter because they mark the boundary between sample and structure. Patricia Lake held a cold, floating test body large enough to expose problems of scale. The prototype was insulated and refrigerated. The project was already teaching its central lesson. Paicrete was tough, but its strength depended on being kept cold. This was not only a scientific story. Canadian conscientious objectors, including Mennonites and Duhobors, were used as labor on the secret work at Patricia Lake. The contradiction was sharp and quiet. Pacifist workers helped build a prototype for a wartime floating airfield, often within a project whose full purpose was hidden. Around the lake, secrecy narrowed the world. There were tools, timber pulp, ice, machinery, and orders. Beyond them stood the mountains of Alberta and the war overseas. Canada now carried the larger experimental burden. Under the National Research Council, tests could move beyond small laboratory pieces toward questions of refrigeration, insulation, scaling, and physical endurance. The Patricia Lake prototype did not prove that a giant carrier could be built. It proved that the program had crossed into engineering reality with a real mass afloat. By summer 1943, Perutz later wrote, small-scale tests had established the material well enough to permit full design work. The idea became a naval engineering study, but the Lake model also clarified the burden ahead. Any future Habakkuk would need cold, insulation, machinery, and control, not merely an audacious recipe of water and pulp. The design on paper no longer resembled a natural iceberg. Perutz described a built structure, a hollow square beam, refrigerated, insulated, skinned against water, and shaped for the sea. Its flight deck was planned as a runway 600 meters long and 60 meters wide. The sea would meet 15 meters of freeboard above a 45-meter draft. The walls were not a thin shell. Perutz's design discussion gave an all-round thickness of 9 meters, a frozen mass meant to absorb punishment and stay cold. The number that changed the scale was displacement. Perutz gave it as 2,200,000 tons, a figure closer to a floating district than to any ordinary carrier. Inside the mass lay the clearest sign of artificial construction. The central void was specified as 884 meters by 43 meters by 43 meters. This was not a natural berg flattened into a runway. It was an engineered cold box, and its survival depended on machinery as much as frozen pulp. The paperwork now climbed above the laboratory. On 30 September 1943, Roosevelt, Churchill, and the combined chiefs of staff discussed Habakkuk in the Allied Conference framework. The project had reached the highest table, but the table was already crowded. Habakkuk now sat beside other emergency answers to floating airfields and amphibious range within the same summit machinery. At noon on 10 September 1943, formal minutes recorded a meeting on Habakkuk's. The spelling varied, and so did the idea itself. Plurality entered the record. American discussions listed naval pontoons, LST-based solutions, and concrete floating landing fields. The ice carrier was no longer alone. It had become one branch of a wider search. One pontoon proposal carried its own hard arithmetic. The strip measured 1,800 feet by 220 feet, required 15,000 tons of steel, and demanded transport by 8 Liberty ships. The strategic weather changed faster than the ice ship could be built. 30 British and 50 US CBEs were in sight, alongside longer-range aircraft, radar, remote bases, and improved shipping protection. By 10 September, priority was moving to 8 British escort carriers, due before 15 December 1943. The ship melted in minutes and production schedules, while the Atlantic problem moved elsewhere. No full-size Habakkuk followed the prototype into the Atlantic. No Picaretty carrier was constructed or deployed, and no combat casualties can be attached to a ship that never sailed. By late 1943 or early 1944, the project was effectively dead. Escort carriers, longer-range aircraft, radar, remote bases, and improved shipping protection reduced the need for an artificial floating airfield. The decisive paper was practical. On 10 September 1943, the ad hoc report placed 8 British escort carriers due before 15 December 1943 ahead of experimental Habakkuks. Something colder remained in the archive. Max F. Peruzzi's Picaretty studies of strength, flexure, and creep became part of a scientific discussion of how glaciers flow. The weapon failed before it became a weapon. Its remains were numbers, tests, and the Patricia Lake model, while the Atlantic was secured by machines that could actually be built. If you enjoyed this video, please like, share, and subscribe. And tell us in the comments which topic you would like to see next.